Hello everybody and welcome to Alex Does LeetCode, where we work on programming problems together live. Hello everybody. So today we're going to do something a little bit different. We will be entering a programming contest. This is LeetCode's bi-weekly contest 119. I've never actually done one of these before, so I'm kind of excited, but a little bit apprehensive as well. So we'll see how it goes. The way I'm thinking about it, the way I think we should do it is I'm probably not going to be super active on stream. Instead, I'm just going to work on these problems maybe quietly. Try to get them done as quickly as possible. We'll probably do that from 9:30 until about 10 when the normal regular stream starts, or whenever. It really depends on how the actual contest goes. At which point we will switch to a regular stream, and I will go through my thought processes as we tackle each of these problems. Now, after I've already decided to join these contests, I realize that some of these problems may not have as much educational value as I was hoping for. So again, this stream is all about teaching all of you guys how to program and how to code properly. And if many of these contests problems are just puzzles or like mathematical questions to be solved, then they may not be as helpful in achieving our pedagogical goals. So we'll see how it goes. Probably around 10-ish. We'll look back and we'll decide. Probably closer to 10:30. Or look back and decide. I may or may not decide to discuss all the problems that we work on today. The other thing that I want to quickly announce is that I'm looking at creating shorts. So these are short videos, maybe 5-10 minutes, that discuss very specific topics. If there are topics that you want to talk about, if you want topics that you want videos on, let me know. Write them in the comments. I will get back to them to you. At the minimum, I think the first topic I want to broach into is probably going to be either list comprehensions or slicing in Python, because these are very unique Python concepts, but they are not unique to programming. Python does them a little bit differently from other languages, but they are not unique to programming. And they are, especially list comprehension is a very good concept to remember and bear in mind. List comprehension is very much the foundation of many programming, I wouldn't say problems, but many programming. Hey there, Shubham. How's it going? Welcome. I think this is the first time I've seen you in chat. Welcome to the channel. As I was saying, list comprehension is a very critical part of many programming tasks that you'll be required to do in the future in your job or even as assignments. So it's something that I want to go over in Python. Yeah, that's about it. And if anybody has ideas or topics that you want to broach, once again, put them in the comments. I can't promise you I'll get to all of them, especially if you write something like, "Oh, let's do some machine learning in Python." That might be too large a topic to tackle, but I'm gonna release some shorts and we'll see how it goes. All right, so we'll wait another 1 minute for the contest to start. Once again, if you just joined the channel, today we're going to do something a little bit different. Hi, Deep Trenjan. First time you are participating in LeetCode contest. So, are you also joining the LeetCode contest? Oh, it's gonna start in 9-10 seconds. So I'm probably not gonna talk as much on stream. But we will discuss once this contest is done. We'll see how it goes. If you're interested in participating in this contest, I think you can still sign up for it. I'm not sure about LeetCode's last minute entries. So jump in here, do this contest with me. Maybe you'll do better than me. Who knows? Okay, first one done. That's not too difficult. Let's see the next one. And once again, if you're just joining today, I'm probably not going to talk as much during the contest itself, but we will circle back at about 10 o'clock or so, and I will go through the things that I got, and probably also the questions that I didn't get, because I don't expect to get every single question in the contest. You're given a 0 index string word. And if for those of you who are on stream, you're highly encouraged to try out these problems on your own. Try out these problems your own. You can probably do them quite quickly, and it's going to be fun because we can do them together and compare notes at in about 30 minutes to 45 minutes. Oh, interesting. A or B or adjacent. Come back to this one. This one is this almost adjacent is, I think it's a pretty classic dynamic programming problem. I'm going to come back to it in a bit. Actually, I shouldn't talk, right? Because some of you might actually be working on this same problem. So I'll leave you to your own devices. Okay. I think this should work. It's probably not going to work. Wait, it's not accepted? Oh, yeah, you can actually get right and wrong answers. Ah, interesting. Interesting. Something wrong with the best calculation. Oh. Right minus left. Okay, so at 6. So right is here. At 6, I see a 1. I see a 6. At 6, I see a 1. So right minus left. So 0 to 6 does not work. Okay, so the best is still a 5. That's correct. Okay. The best left is 1 and the best right is 6. Oh, is it just +1? Wait a second. Yes, +1. No, that's not right. There's some off by 1 logic here. I think we're fairly close. Some off by 1 logic here. Let's see how this goes. Okay. Best equals right minus left. Okay. So best should be 2 instead of 1. Yeah. It's off by 1 on the left. But it's okay. We'll keep going. Which should be fixed at the end with the best +1. So left minus right. Left +1. Oh, I see. So when I need to decrement this also. Decrement this also. Let me try that. Num's left equals to num. Let me see if this works. Oh, accepted. Nice. Alright. Cool. Okay, let's try the third one. Oh man. There's a company with N branches across the country, some of which are connected by roads. Initially, all branches are reachable by traveling some roads. Wow. Max distance. Okay, so this is a graph problem. Oh, interesting. IUV. Okay, interesting. So, does every pair of branches have at least one road? That's my question. Because if they don't, total length needed to travel from one branch to another. Then, if they don't, then I need to run Dijkstra. I need to run Dijkstra first on the road. You know what? Let's pretend that they do first. Let's say that this graph is at least a click. So a click plus. So a click is a graph that where every node is connected to every other node. There can be multiple roads. Are there branches? Are there at least pairs of branches with no direct roads between them? If there isn't, let's assume there's a click plus first. Maximum cover set. So let me see.
U and V are integers, right? Okay. All right, I'm back. Okay. Okay. So now we have a set of pairs. This is similar to minimal cover set problem. I don't remember what it is. Okay, I'm going to go back to the other problem and see if I can solve the other problem quickly, because I want to make sure we have time to go through the problems that I did solve. Remove all adjacent almost equal characters from the word. Oh, interesting. Oh, this question is easier than I thought it would be. I see. So remove all adjacent. If it's okay, let's do it the naive way first and see what happens. See what happens on this one.
Oh, done. Oh, easy peasy. Wait, I have 3 out of 4. Oh, nice. I'm doing way better than I thought I would be. Hey, Culpit, how's it going? Are you going to do all LeetCode contest streams from now on? I don't know. I think it really depends on how this one goes. The purpose of this stream is not contest or to solve LeetCode problems, but really it's pedagogy, it's teaching people. So if I feel or if my viewers feel that doing LeetCode contest is a good way to learn, then I will do it. If it's not, then I probably won't. Yeah. But it does look like people are coming. So there's a good chance I'm going to repeat this, at least in the future. But Culpit, I hope I'm getting your name right, by the way. Feel free to drop a comment and let me know if this is something that you like. And welcome everybody to my channel. I'm going to work on this a little bit more. I don't think I'm going to end up finishing this problem because I suspect it's going to be a pretty hard problem. But maybe in about 5 or 10 minutes, I'll see how far I get. And I want to have time to discuss the problems that I did finish, the other 3 problems, and make sure we go through them. And if there are people on stream who for sure will wait for streams, I really appreciate this, Shuvam. I really do. If there are other folks on stream who have been tackling this contest alongside me, feel free to jump in the chat. And if you don't mind, I would love to see your solution because I'm curious what other people are doing. Let me see. So minimum cover sets for the pair. Let me think about it a little bit. This is a very standard algorithm. I just don't remember what it is right now. So basically what I'm thinking about is now I have a pair. I have a set of pairs that look something like this. I have a list of pairs that look something like this. And these are all the pairs of branches that are too far away from each other. And so the idea is I need to produce a set of branches that I can remove that cover every single thing in this pair. So let's say this is something like okay. In this case, I'll remove B. Removing B will remove the first 3 pairs. You can see AB, BC, and BD are far away from each other. If I get rid of B, then I remove these 3 things. And then I have to remove X and Y. So B and X, or B and Y, would just cover all of this. So this is similar to I don't know what's the name for it, but I think it's something like minimum cover sets, or it's a permutation of the minimum cover sets problem. Hey, Out4 Gaming, hi bro, welcome. Dang it. So I can't do it naively, because if I just go to first pair and remove, let's say A, then B will still be here. I go to second set and serialize, hey, B is still here. So I remove B. I'll end up removing A, B, and X, which is not what I want. So another way I can do it is just count who is the person with the most number of offending pairs. And remove that guy. I can do that. I feel like that will get me most of the way there. I'm probably gonna do that. And then I want to leave some time for discussion, so I do want to have some time left to talk about what's the best way to do it. Pair. Okay. Let's pair dot first. I don't remember the syntax. Is it 0? Okay. Huh. This is kind of a greedy approach. Hey, Coding IT, welcome. Nice. Some of you guys are also working on the programming. Also working on the problems. I would love to see what are some of your approaches. I bet some of you will find more efficient or even faster algorithms than me. So I'm eager to see what you guys come up with. But I want to do another. I'm already. Min cover set for pair. Yeah. I want to try out this one. I think I can find what the answer is. I think I'm close. So I'm going to try this for about 5 to 10 minutes. And then we will see what happens. Minimum cover set for the pair. So I have a list of bad branches, and I have them by I have the count, so I know who is the worst branch. So maybe what I'll do is I'll just delete the worst branch. I'll sort the dictionary by keys. How do I sort dictionary by key? By value. Sending Python. I don't remember. There's a quick and easy way to do it. Something like this. I think this will work. Reverse equals true.
Okay. Minimum cover set for pair. So I basically sorting. So I have a dictionary that contains all the bad branches, sorted by how bad they are. So now I am going to take this and I'm going to for branch in bad. Oh, 5 is the pair. I've got to do it that. This is really not the best way to do it. Okay. Disjoint set for a problem. Yeah, it's one of these classic problems. It is one of these classic problems. Runtime error. Sorted bad, yes. Wrong answer. Ugh. Output 3. Expected 5. Okay. Wait, why is it expected 5? Five possible set of closing branches. Number of possible sets of closing branches, so that any branch has a distance. Oh, I'm not supposed to. I see. So I was mistaken. So I misunderstood the question. Okay, so that any branch has a distance of at most max distance from each other. I see. Possible sets of closing branches. I see. Okay. Okay. So this is the part that is wrong. This is the part that I got wrong. I need to redo this. Yeah. Okay. Well, I think let me see how chat is doing. Okay. Yeah. Power 5. And it's 10. So it looks like there's an easier way to do this. It looks like there's an easier way to do this. I can generate all I can generate the power set. Oh, so that's a much easier way to do this than what I'm doing. Okay, all right, cool. I think it's time to call it. So I'm gonna stop working on the programming contests. I guess this is where I am. I got 12 points in about, honestly, it's in about 40 minutes. I think I spent way too much time on the last one. I want to check on how's chat doing. So how's everybody doing? Who is actually working on this? It looks like Outfall Gaming and Coding IT actually worked on this, right? Outfall Gaming. If you guys are here, feel free to let us know in the chat. How did you guys do? Did you guys manage to finish all 4? Send the second code bro in comments. Hi Ganesh. Send the second code bro in comments. So Ganesh, no worries. We'll be going through the first 3 problems. The last one, I might try it again. So welcome, Tam Hill Kuk. I'm pretty sure I got your name wrong. Apologies for that. Lamau, I got a test case wrong on 4. I don't know how it's wrong. Nope, just 3. You know what? I'm gonna redo the 4th one. I'm gonna try and redo a 4th one on my own time. Well, Tam Hugh Kuk, you probably did better than me. I couldn't get the 4th one to work at all because I misread the problem. So I went about it a completely wrong way around. But I'm gonna retry it. So how did you guys do? Did you guys all finish? Anybody got all 4? Let me know in the chat. Alright, what could be the approach of the 5th one? So you mean the 3rd one, right? The one with 5 points? Okay, cool. Let's go over some of the questions. Let's start from the first one. And I know you guys look like you're more interested. You guys don't look like you're interested in the first one at all because it's an easy one. Floyd Walshaw for 4. Floyd Walshaw. That's interesting. I've never heard of that before. I might Google it. Thanks, Tam Hugh Kuk. Second test case of Jason almost. Its output should be 1. Floyd Walshaw algorithm. I'm gonna look it up. I might, I'm now very invested in the 4th question. I'm probably gonna work on it on my own time off stream, and once I figure out what the right solution is, I'll make a video on it. I may or may not do that on stream, but I'll think about it. For the sake of completeness, in case there are other people watching this after the event, I do want to put this in the vault. I want to go through all the first 3 problems, including the first one, which I think from what people sound like in the chat, they don't have problems with this one. Alright, so the first problem is find common elements between 2 arrays. You're given 2 zero-index arrays, nums1 and nums2 of size n and m. So what we need to do is to calculate the indices such that the number of things, essentially what it's saying, this is a lot of words. So basically it's saying that you're given 2 lists of numbers. Calculate the numbers, the number of things in list 1 that appear in list 2, and calculate the number of things in list 2 that appears in list 1. So in this example, this 3 appears in list 2, this 2 appears in list 2, and this 3 also appears in list 2. So there are 3 things in list 1 that appears in list 2. So you have 3 in the first place. And there are 4 things in list 2 that appears in list 1. So 2, 2, 2, and 3. So notice there's a lot of repetitions. We count all the repetitions. So this is 2, 2, 2, and 3. Even though there are 2 distinct numbers, there are 3 occurrences of 2 in list 2. We count them as 3 separate things. And then number 3, which is a 4th separate thing. So we get 3 and 4. We get 3 and 4. Okay. Make sure I don't miss any chat messages. Welcome, Piyush. Can explain the second test case of adjacent almost character. Okay, we'll talk about it. I was actually surprised that I got that one right. I thought it would be a little bit more tricky. A little bit more. There might be other special cases, but we'll go through it one by one. Okay, so for this problem, this is not as difficult as the other 3 problems. So the right way to think about it is you can think of these as 2 separate questions. Question number 1, how many things in list 1 appear in list 2? Question number 2, how many things in list 2 appear in list 1? So when I wrote it, I actually wrote it as essentially 2 separate solutions. So to count how many things in list 1 appears in list 2, well, this is pretty straightforward. I think you've all covered this in any beginner Python class you go through, which is you go over the things in list 1 for I in nums 1, and then you have a check. In Python, we have, Python is really idiomatic for this kind of things. You want to check if something appears in a list, you just say I in the list, right? This is really convenient. This is one of the things I love about Python. If it does appear, you say count 1 plus equals 1. And at the end of you get count 1. Likewise, for the other way around, you just flip it. So for I in nums 2, just go through all the things in the second list, check if they appear in the first list. If they are, incremented by 1, and then return count 1, comma count 2. So this is fairly straightforward. I don't want to spend too much time on this. Let's go on to the next one. So remove almost adjacent characters. Okay, so this one actually, so let me explain for those of you who are not on stream or didn't get a chance to try this. Let me just explain this real quickly. Basically, you have a string, right? So what you want to do is to remove or replace characters in the string. You have to keep replacing them until there are no 2 pairs of characters adjacent or right next to each other that are either the same character or 1 character away. So A and B are 1 character away. B and C are 1 character away. B and D is 2 characters away. So this is fine, right? So this is fine. So the idea here is we want to count how many characters we have to actually delete. Well, not delete, but just move far away so that you will not trigger this almost equal characters rule. So you end up with a string where no 2 characters side by side are either the same character or 1 character away, 1 letter away. Okay, so for instance, this one, you can do Y B D O E Z. Okay, so for this, I actually did a greedy algorithm. So this is a trick that you can only use, unfortunately, you can only use in programming contests, which is you try something and then you run it and see whether it works. Okay, this is a trick that, unfortunately, programming contests reinforce, but it's not something that I'm proud of doing, and this is not something I would normally do in the production code. The idea is I want to know if the greedy algorithm works. The greedy algorithm doesn't always work, but in this case, it seems to do. I want to know whether it works. And another benefit is I try it with these given test cases. If it fails on a specific test case, then I know, hey, here's an example where greedy fails. Think about this kind of problem, this kind of example, this kind of failure, and see if you can generalize it and come up with a better algorithm from there. So I was actually, when I wrote this algorithm, I thought it's going to fail. I was like, I'm going to submit this, it's going to fail on something, I'm going to see what the failures are and fix those. But it turns out to work. Okay, let me explain the greedy algorithm. So basically the greedy algorithm, actually, let me see. Actually, there was a question, right? About second test case of adjacent almost. So Piyush had a question. Welcome Aman and welcome Atif. Welcome Muhammad Zihan. I will not solve question 4 today. I will solve it off stream once I think about it a little bit, because I got really off track and I don't want to take another 1 hour to fix this. But I want to think about it a little bit. I will solve it and I'll release it either in a separate standalone video, or I will do it on stream the next time I'm live. So Piyush had a question about second test case of adjacent almost character. So let me make sure that we talk about that. So adjacent almost character, the answer is 2. Because you look at this, what are the offending pairs of characters? A and B are next to each other. So you need to change one of them. Okay? D, and E, these three are all next. D and D is the same, and D and E are next to each other. So you need to change. You need to change something here so that they are not. There's no two characters side by side that are offending. So the easiest way here is just change the middle guy. So D, D, E, right? Just change the middle D to something else. Then, like X or Z or whatever random number. So this way, the guy on the left and the guy on the right will both not conflict with you. Right now, both the guy on the left and the guy on the right are conflicting with you. So if you just change the middle guy, you'll be done. So it changes to O, but you can change it to anything you want. So the answer is 2. So Y and O. Note that in this pair, you can actually change B also. You don't have to change A. It says YB, right? You can be AY or AZ or A whatever random one. So I hope that answers your question, Piyush, about the second example. Okay, so the way I did it is actually a bit of a greedy thing. So my idea is I'm just going to go down the list. Let's pick this one. I'm just going to go down the list. I'm going to start with A, B, C, right? This is what I'm doing here. While I smaller than length of word, I is basically going down the list. And then there's I plus 1. The reason why I want to use 4, I'll show you later. Okay, is I'm going to go down the list with I. And the way it works is I starts from 1. So it doesn't start from A, it starts from B. It starts from the second character. And the way it works is I'm going to go down the list. I'm going to check, am I in conflict with the guy before? Am I am I not a bad character, right? So I start here, and B turns out is a bad character because B conflicts A. B is too close to A. So if I find, so this ABS ORD, so ORD turns what I gets the character. It gets the ith character from word. Okay, this is standard indexing. I think most of you will be familiar with this. ORD, if you're not familiar with this, ORD gives you the ASCII code of the character. So ASCII code of small letter A, ASCII code. And if there's demand for it, I can go over it in a different video. So A is going to be 95, B is going to be 96, C is going to be 97, so on and so forth. So ASCII code basically is like the encoding of each character, or basically every symbol you have in text to a number, so we can store it in our computer as binary. So I'm checking if the ASCII code of the character at I is minus the ASCII code of character at the I minus 1. If their absolute difference is smaller or equals to 1. So this basically checks if the two characters are side by side. If word at I is going to be adjacent to word at I minus 1. Okay? If it is, I will just say count equals count plus 1. So if it isn't, I'm just going to move to the next I, right? If it isn't, like this one isn't, Z and E isn't, well, I'm just keep going go. If it is, I'm going to do count equals count plus 1. I need to change the character at I. I need to change this guy because he's offending. He's a bad character. And then I do I equals I plus 2. Why do I do that? So let's say I is 1. I is B, right? I is B if, look at this, B conflicts with A. Okay? B conflicts with A and I need to change B, right? B conflicts with A, so I need to change B. As I don't know now, I don't care what I change B to. I'm going to assume I'm going to change B to something really far away from A. Not only that, I am also going to make sure I change B to something that is very far from the next guy, D. So I'm guaranteed that this guy doesn't conflict with the one before, because the one before, this I here, was changed. I'm going to assume I'm smart enough to change this word I to something that doesn't conflict with word I minus 1 and also does not conflict with I plus 1. So I'm going to assume that this is changed in a way that this will never conflict. That's why I do I plus equals to 2. That's why I do I plus equals to 2. So that's the sort of trick here. Otherwise, I just do I plus equals 1. I don't do anything about counts because there's no conflict. Now, take for instance this x, edge, m, whatever, blah, blah, blah. Okay? Take for instance here, to give you a very concrete example, when I equals to 1, word I minus word I minus 1, there's a conflict here. So once again, to reinforce the point, when I change this, I want to make sure that I don't change it to something that conflicts with the next guy. So whatever I change it to, I'm going to assume that the next guy does not conflict. Okay? So this is a very greedy algorithm. This assumes that I'm also, like, the moment what I'm doing here is when I see a conflict, boom, I changed it right away. I fixed it right away. Right? That's not always the right thing to do. For instance, in this one, I will change B. I won't change A. Right? And answer, they change A, but I don't change A. My answer changes B. But the thing is, because all I have to do is to return the count, the number of changes, I believe, and I'm pretty sure I can prove it mathematically, that it doesn't matter which one I change, it's going to end out the same anyway. So there's a way to show that the greedy algorithm is optimal. No problem, Piyush. My pleasure. Again, I monitor chat quite closely. For those of you who don't know, I actually teach an online class at a university. So I'm an adjunct professor. So I'm used to monitoring chat. So feel free to type your questions in the chat. I will get to them. Okay. Cool. So that's all for question 2. I'm going to go on to question 3. If you have questions about question 2, just put in the chat and let me know. Question 3 is interesting. Question 3, oh my god, okay? Now, I'm going to say something about question 3. If you are planning to interview in the near future, and you're coming to this channel to brush up on your LeetCode, then I'm going to give you a bit of a hack, which is question 3 is exactly the kind of question that comes up a lot at these kind of tech company interviews. Okay, I swear to God, this is the most common question that I see all the time. It comes up all the time. So if you can master something like question 3, then this will give you a huge leg up if you're going to go interview, do technical coding interviews. This is exactly the kind of thing that they ask you. With that said, let's go into what question 3 is. So question 3 says, you're given an integer array nums and an integer k. The frequency of element x is the number of times it occurs in an array. An array is good if the frequency of each element in this array is less than or equals to k. Return the length of the longest good subarray of nums. This sounds like a lot of words, but let's break it down slowly, okay? Let's break it down. So basically it means that we're looking for the length of the longest good subarray. The longest good subarray. What does good mean? So first of all, what does subarray mean? Subarray means contiguous, non-empty, blah, blah, blah. So subarray is just like some sub piece of this giant array. Okay? Subarray is some sub part of this. There's a left, there's a right, there's just like some subsection of this giant array. Okay? And we're looking for a subarray that is the longest
good subarray. So what does good mean in this context? It means that it cannot have more than k repetitions of the same element. I cannot hate that these are numbers. I wish they were letters. It would be easier to explain. So take for instance, in this example, right? K is 2. The maximum number of times something can occur is twice. If you look at the whole array, it's not a good array because the number 2 appears 3 times. 2, 2, and 2. So this number 2 breaks nums, breaks the constraint here. So nums itself, the whole thing isn't a good subarray, isn't a good array. So what we need to do is to find the longest possible subarray, which this is true, where things appear up to twice. So if you look at it, eyeball it as a human, you can easily see that this is the longest subarray, right? Because 2 is the guy that's offending. 2 is the offending element here. 2 is the guy that is breaking the rules. So I need to get rid of at least 1, 2. So all I have to do is take this, right? 1, 2, 3, 1, 2, 3 here. The first 1, 2, 3, 1, 2, 3. Oh, sorry, 1 also offends. So I need to do 1, 2, 3, 1, 2, 3 here. I need to get rid of these 2 guys at the back. And this would make my array good. Everybody here, 1 only appears twice, 2 only appears twice, and 3 only appears twice. So this subarray is good. This subarray is also good, just to make for argument's sake, but it's not the longest subarray, right? In fact, any one single element is a good subarray, but it's not the longest good subarray. So we want the longest good subarray. Okay, likewise this, k equals to 1. This is even stricter. Every element can only appear at most once. 1 appears 1, 2, 3, 4 times. 2 appear 4 times. Well, that's kind of pain. The best possible subsequence that we have is going to be 1 and 2. Oh, okay, cool. Now that the question is clear, how do we do this? Okay, so this is actually... Okay, hi, Tripura. Welcome. Question 4, I'm going to do separately. I'm not ashamed to say that I got stuck on it a little bit because I misread the question. So I'm going to try and do it off stream. And then it sounds like people want to, it sounds like there's interest, right? So I'm probably going to release a video, or I'm going to explain it on stream the next time I'm live. So one of the 2 things. Okay, let's see. Okay, so I think this is a trick that I want to teach you guys, because this trick appears a lot in coding, in those like LeetCode interview type questions. If you want to find a good subarray, one way to do it is to test every combination. So one way to do it is to, test every combination, every possible subarray, find the longest one. This is going to be like it's going to take exponential time. It's going to take n factorial time because you're choosing a combination, which is not good. Instead, what we want to do is the following. Okay, well, I'm going to teach you guys this trick that will come in really handy for this problem. I'm going to show you a few other problems that also use this exact same strategy or modifications of this strategy. I'm pretty sure I have at least 2 other problems that I've done on stream in my channel. There's also one other problem that, interestingly enough, I gave to my students as homework a few weeks ago that reads the exact same trick. So this is a trick that, if you interview for like Google or Facebook or whatever, they will ask you a lot. So make sure you know this trick. And for those of you who already know this, good. Welcome, Shiva. Welcome. Question 4, I'm going to do that off stream because that takes a bit longer. Okay, so the trick here is basically, because this is subarray, right? I'm going to have a left and right pointer. I'm going to have left and right pointer. Left, right, okay? So initially, my right pointer, oh, how do I select? Initially, my right pointer and my left pointer at the beginning. And the idea is this. I'm gonna see if my right pointer is at 1, is at index 0, is like this guy right here. Right? If my right pointer is here, what is the longest sequence I can have? Okay, where's the furthest I can push my right pointer? If my left pointer is here, where's the furthest I can push my right pointer? Okay, that's the game we're gonna play. If my left pointer is here, I want to push my right pointer as far as I can. I'm gonna talk about this in like very abstract in general terms, because this is a trick I'm explaining. After that, I'll show how to apply this trick to the problem. And I'm also going to show you some other questions I've done in the past that use the exact same trick. Okay? So it's very important to learn this trick. I think this is, to me, the best takeaway from today. I'm going to push this right pointer as far as I can. So if my starting is at 1, the furthest I can push my right pointer is going to be here, right? I can get all the way here without breaking any rules. Does this mean that this is the optimal array? No, because it's possible that I can move my left pointer a little bit more to the right. It's possible for me to say, move this guy a little bit more to the right, and then move this guy all the way to the end, right? I can get an even more optimal answer by moving my left pointer. Okay? I can potentially get a more optimal answer by moving my left pointer. So what I do is, first, I move my right pointer all the way as far as I can. And then when I reach here, I say, well, maybe I can push my right pointer a little bit more if I'm willing to move my left pointer. So I'm going to move my left pointer. And this time, the nice thing is, I don't have to go back and check all of these. My right pointer cannot be any of these. Even if I like any of these guys are valid, they don't give me the longest array. I want the longest subarray. If any of these guys to the left of my current right pointer is valid, they will still not be my optimal solution. So my optimal solution must lie further out to the right. So I will keep moving. I play the game again, keep moving my right pointer, see how far I go. Okay? Until I reach the end. And then when I reach the end, I know, I basically have the optimal solution. So at every time your left pointer gets stuck, every time just before your left pointer moves, you record what is your sort of best subarray you found so far. Okay? So I'm talking about this in very general terms because I want to see if I can distill the essence of this trick down. This trick with like 2 pointers where you start, sliding the right side out as far as you can until you can't, and then you move the left by 1, and then you keep sliding the right side out by as far as you can. So this, I'm going to show you guys later, actually appears in a lot of other problems, including one I solved on my channel, as well as one I gave to my students homework last week, and also one, the most classic one is the highest and lowest stock price, which if you are a fan of LeetCode, you would have seen. Okay, so now for the specifics. And for those of you in chat, I don't see a lot of demands about this problem. If you will, I'm curious if you guys have found this
has found this question easy. If you guys solve this question easily, or if you guys know this trick. If you know the trick or you solve the question, let me know. Let me know in the chat. It sounds like many of you did questions 1, 2, and 3. You just didn't do 4. But let me know in the chat if this is the same thing you did. If you did the same thing as me. So this is what I'm going to do. Okay? I'm going to have left and right as pointers. They both start at 0. But they are left and right. Okay? I'm going to have these freaks here. I'm going to have best. Best is basically the length, the longest subarray that I found so far. So the length of the subarray is right minus left. Is right minus left. And because because of the way I do these things, is actually right minus left plus 1. When the left and right are on the same number, it's not 0, it's actually 1. Right? And frequencies is how I keep track of how many times a number has appeared. So these 3 things are general. They're used for the trick that I just described. This freaks is just for this problem. This problem you have frequency. So this is how I'm going to do it. So I start with left equals 0, right equals 0. They are both equals to 0. Okay. And then I'm going to move right as far as I can. I'm going to move right as far as I can. So nums equals nums right. So I'm going to keep moving until... And as I move, I'm going to record the next number I have. So I see a 1, right? I'm going to say 1. I've seen it once. And then next I see a 2, right? I'm going to move this right arrow. For those of you who just joined, I am going to spend a bit more time on this problem because this problem I think has the most teaching value. It's not the hardest problem, but it has the most teaching value because you are going to see problems like this many, many, many times. So 2 is 1. So 2, the number 2 appeared once. I'm going to keep going. I'm going to keep going with this. And then now 3 appears once. And I'm going to move all the way here. My frequency array will look something like this. So 1 appeared twice, 2 appeared twice, 3 appeared twice. So far, so good. So far, none of these guys have violated K. You see down here? Freaks larger equals to K. Smaller equals to K. Yeah. So far, none of them have violated K. These are all legal versions. I keep moving my right. My right pointer keeps moving. Right? My right pointer keeps moving. Best equals to right minus left if right minus left is larger than best. Right? I keep moving until I get to a point where frequency num is larger or equals to K. This is what happens here. At this point, this violates the array. This violates the constraint. So now I violate the constraint. My right pointer has moved so far that I have 3 1s now. And so that violates the constraint. This is bad. So what happens if this is bad? Well, I have to move my left pointer until I fix it. Oh, I have to be careful about this. I need to move my left pointer until I fix it. And how do I fix it? Well, I have to move until I find a 1. And I delete that 1. So thankfully, the first number I see is a 1. So let's say, for instance, this is 2. Okay, this is a 2 instead of a 3. Right? I will have to move my pointer from here to here. So I delete this 1, right? I remove the 1, so I remove that 1 from freaks. While left is smaller than right, I'm going to move my left pointer now. If num's left equals to num, because I know that num is the offending number, right? I have to keep moving until I can find another copy of num so I can delete it. So I keep moving, left plus equals to 1, and then freaks num minus equals to 1. So I have to keep going until I reach this 2. Okay? So now, this is another good array. From here to here. Because there are only 2 copies of 2, and that is fine. But this array only has 5 items. So this array is not as good as best. Best was at 6 items. This is only 5 items, so we don't replace it. And so what we do is then we'll repeat this sequence, okay? So now I would I'll move this right arrow again as far as I can, and whoa, the moment I move it, I see another 2. That's not good. That's not good, right? So now we have 3 2s. We have 3 2s. This violates our condition. So we have to move the right pointer again. Sorry, we have to move the left pointer again. This time we have to move it all the way to here to get rid of this 2. We need to get rid of this 2 right here. And now this is another array, another sub-array that is good. And then we'll have to compare it to best again. But in this case, it's of length 3, so again it's not as good as best. So we keep going. So what is the time complexity of this? Well, you can actually show that the time complexity is O(n). You might think that is O(n) squared. You might think that is O(n) squared because there's a loop inside another loop. However, if you look at it closely, this inner loop is not O of n, but this inner loop only sort of like the left pointer only keeps going once. It doesn't start from 0 again. So when I move the left pointer, I don't go back all the way to the start and move it starting from 0 again. I keep going from where I left off. So left only move from left goes from here. Oops. Left goes from here to here. Right goes from here to here. So it's O(n). It's actually 2n because that's left and right. But you know, 2n is the same as O. O of 2n is the same as O of n. Okay. Versus the other brute force solution, which is to calculate what if there are 3 adjacent 1. Piyush, is that that sounds like a question about problem 2, right? I'll get back to it. I'll get back to it later. But I want to finish up problem 3 now. Okay, so this is basically time complexity wise. This is O of n. The brute force, which to generate the power set, O of n factorial, which is very slow. Okay? So, and bear with me, because I'm spending a lot of time in this problem. I think it's very, very important. Actually, let me go to my YouTube channel. And also LeetCode. So why is this important? Because
there are a lot of questions that actually use the same. Yeah, so best time to buy and sell stocks, best time to buy and sell stocks too. Both of them use the same strategy that I described here. So both of them use this array with these left and right pointers. They're done exactly the same way. Okay, so my videos. Let me see, the mountain one. Yeah, this find highest altitude. Oh, find container with most water. This one, which is actually pretty problem. Which actually takes a while. Find container with most water, and yeah, I don't know if there's another one. Yeah, find container with most water. This one uses the same. This one. Okay. So this one, find container with the most water. This one actually uses the same tactic, the same trick as I described here with the left and right pointer. So this is a really, really good trick to learn if you're doing tech interviews. Sorry, no problem, no questions are stupid. If there are 3 adjacent to 1, let me see. If the 3 adjacent to 1. So this one, you don't have to worry about adjacency. You just have to worry about how many times something shows up. You just worry about how many times a number shows up. So you don't care about which one is adjacent to which one. In this case, in this example, 2 is a bad number because it shows up 4 times. And k, the k we have here, k equals to 2, it should show up 2 times maximum. It's showing up 4 times. So that's the problem with this. I hope that answers your question. Okay, so let's go back to question 4. I'm going to describe briefly what my strategy was. Okay? I'm going to describe what my strategy was. I'm going to and where I went wrong. It's going to be a very humbling experience to describe to a live audience how I messed up. I'm sorry, guys. But I'm also going to see if I can describe how I would try to solve it next time. So unfortunately, it might take a while, and I'm going to close my stream pretty soon for lunch. So I will have to I will do this question off stream, and then I will try to present the solution to you guys in a separate video. Okay, so if you're interested in this, watch out for that video. Okay, so the question here is this. There's a company with N branches across the country, some connected by roads. Initially, all branches are reachable by traveling roads. You want to close branches. Let me just reload this. Normal. Okay. You want to find all the possible sets of branches that you can close, such that any one branch has a distance of at most max distance from each other. So take, for example, this example. In this example, you have branch 0, branch 1, and branch 2. Branch 0 and 1 are close to each other, right? They're only 2 away. But branch 3, this branch right here, he's very far away from his friends. He's 10 away. So I want to close this guy. In order to get to a place where how do I say this? So you have to close this guy, and once you close this guy, you'll be good, right? Everybody is near each other. But so initially when I read this problem, so the sort of misconception I had was I thought we were supposed to find the minimum number of branches to close so that you don't have branches that are far away. But that's not what the question is asking for. And this is my bad. I should have read the question more carefully. The question is asking for this. You had to find all the possible sets of branches. You have to find all the possible sets of branches that after you close them, you will get something that is valid. And you have to count how many sets these are. And so this is very interesting. This is a completely different problem from what I had in mind. So for instance, in this example, let me just wipe this example away. For instance, in this example, you can close branch number 2. And they're reachable to each other, blah, blah. So this is fine, right? You can also, let me erase this properly. You can also close branch 2 and 1. You can also close branch 0 and 1. And it's kind of stupid if you think about it. You're closing 2 branches because one guy is far away. You keep the guy who's far away. Well, you know what? It is what the question is asking for. So closing 0 and 1 is also valid. You can close 1 and 2. This is also valid because the only guy remaining is 0 and he is of course is nearby himself. It sounded counterintuitive to me. This sounds like, it is, I know it's a question, but like you won't do that in real life, right? In real life, you have a branch that's far away, and like you close the guy, right? You close this guy who's far away, and you're like, we can also close people who are near. Like you don't sort of intuitively want to do that. So that part sort of tripped me up a little bit. But the question is asking what it's asking. It's really asking for a set. It's the number of possible combinations of branches that you can close such that they're all reachable to each other within distance 2. I will have to think about this a little bit. Okay. So the other thing that's tricky about this question, the other thing is a little bit tricky, is that I think I'm working off the assumption that every branch has one road leading to each other. Okay? And the roads have weights. But this is not always the case. Maybe because the data structure we're given is a list of roads. It's a list of roads. You see, it's a list of roads. So it could very well be that some of the branches don't have roads. Right? This branch and this branch, maybe, I don't know whether this is true. I'll have to actually do the question, like solve the question and find out. Like these guys don't have roads to each other. These guys don't have roads to each other. So to get from here to here, you need to travel along this road and then come down. So the distance from him to him is this plus this. Let's say this is 1, 2, and 3. Right? So this is effectively 3. Because you have to go 1 here and then you pay another cost to go here. Okay? So if this is possible, so there are examples, that's why I say click plus. A click is basically a graph where all the nodes are connected to all the other nodes. Where all the nodes are connected to all the other nodes. This is a click plus because they have multiple edges connecting two nodes. But it's a click because every node has at least one edge to every other node. I don't know if the graph they give me is a click or not. I don't know. They could give me a graph like this, in which case I have to work out that this guy and this guy has cost 3. So to do this, you need Dijkstra's algorithm. But now that I'm thinking about it, I don't think I actually had to work this out. I think there are easier ways to solve this problem. Because what they're looking for is not the best brunch to close, which is what I assume, which again is what, if you're a brunch manager, if you're the owner of a bunch of McDonald's, this is what you'll be thinking about, right? Instead, they're looking for the number of set, the size of the set. If they're looking for size of the set, that's a completely different ball game. Okay, cool. So I won't be doing this problem on stream today. Instead, I am going to think about it a little bit. I'm going to do it off stream. I will have to, I will upload a video on it once I figure out what it is. Let me see. So I know that some of you guys are asking for question 4. Thanks again to everybody for being here. If you don't mind me asking, for those of you who are still here, I know a large part of my audience is from India. So yeah, I've never been to India. I grew up close to India. I grew up in Southeast Asia. It's not too far away. If you're from India, shout it out in the chat. I would love to see your country being represented. Welcome. And more importantly, sorry, my actual question is, if you're dialing in from that side of the world, let me know if this time works for you. Is it too early? Is it too late? Because I want to adjust my streaming schedule to work for a global audience and not just people in the United States where I'm based. Okay, so that's all I have. I think somebody, let me see. So Tam Hugh Ka, I'm sure I butchered your name, suggested a Floyd-Warshall algorithm. I've not heard of that, but I'm going to look it up. Okay, I'm going to look it up. So that's it. That's all I have for today. I will release a video for question 4. And I'm going to stay in chat a little while. I'm going to turn off the stream and stay in chat because I see that Piyush has asked some questions. So Piyush, I do want to answer your question. So I'll stay in chat for a few more moments. For everybody else, take care. Thank you. I really appreciate all of you for coming here. I really appreciate you for speaking up. I try to interact with my chat a lot because I teach online in a university and my students also talk in chat. So I really enjoy all of, I'm really grateful actually for all of you for being here, and see you next time on Tuesday for another LeetCode problem. Thank you. So Piyush, I will hang back. Everybody else, take care. Bye-bye. Given value n, find out the value k, where after all k value additions will be same as addition of value before. So input 49, output 35. Oh, interesting. Oh, interesting. Okay, so I can help you with this, Piyush. So this is actually a math problem. So you need to know how to do a sum of an arithmetic progression. And if you don't know what this is, because Piyush, I don't know how old you are or where you are in school. I remember I learned this in in high school. I don't know what the equivalent of that is in your country. I assume that Indians, your math is really advanced. It's more advanced than us Americans. So I assume that you guys probably know this better than me. But this is a math problem. Basically, you need to find out how to do the sum of an arithmetic progression. And it looks something like this, if I remember it correctly. So it's n. So what you need to do is to Okay, you need to get n. Slash 2, right? That's your big number, right? That's your input. And then you divide this number by 2. And you calculate let's call it sum. Divided by 2 to get sum divided by 2. And then you have to find x plus 1 slash 2 such that x plus 1 times x divided by 2 equals to sum divided by 2. Okay? So sum is 600, and so sum from 1 to 49 is 1260, right? So you divide by that by 2 to get 630, and then you calculate, calculate this x plus 1 divided by 2 equals to sum, do some math, and you can figure it out. So this is probably not a programming problem. You can also do it using programming if you want to. I think that's actually, is good practice for your programming skills. If not, then math is perfectly fine. Okay, I hope that answers your questions. Thanks to everybody for sticking with me during the LeetCode contest. I will try to do more of these in the future, but probably not right away. Thanks. That's all for today. Bye bye. See you next week.